In this section, we will understand about irrational numbers. So now irrational numbers we have also done in ninth class, and we will recall certain facts we have already studied, and we will proceed further. Okay, now what are real numbers? Real numbers are the sum of all the rational numbers and all the irrational numbers. Okay. Now, what are rational numbers? A rational number is any number which can be written as p by q in the form of p by q, where q is not equal to 0 and p and q are integers. For example, we can say 7 by 8, right? We can say 1 by 2 because 1 is an integer, 2 is an integer, and 2 is not equal to 0. 7 is an integer, 8 is an integer, but 8 is not equal to 0. So these numbers are rational numbers, right? Now, what is an irrational number? See, a rational number is a number that can be written as p by q, q not equal to 0. So an irrational number, what is an irrational number? An irrational number is a number which cannot be written in the form of p by q, where q is not equal to 0. Now there are infinitely many irrational numbers just like rational numbers. We know there are infinitely many rational numbers and there are infinitely many irrational numbers. So there are infinite number of real numbers. So the examples of irrational numbers are root 2, root 3, root 5, pi, 0.1011, 0, 111, 0, 1111, 0, and so on, right? Now we will understand how these terms are irrational numbers. Now, first of all, we will understand the decimal expansion of a real number to identify which number is rational and which number is irrational. So, for example, if we are given a real number and we find the decimal expansion of that number, we will understand from that if it is a rational or an irrational number, right? So, if we divide p by q, where q is not equal to 0, there will be two cases. First case, first case would be when the remainder becomes 0, right? After some steps. ठीक है. For example, if we have 7 by 8, if we divide 7 by 8, we get 0.875. If we divide 1 by 2, we get 0.5. So after this 5, we do not get any other number over here. After this 5, we do not get any number over here. So the decimal expansion stops at 5 here and it stops at 5 here. So the decimal expansion terminates after a finite number of steps. So here the decimal expansion is terminating. Okay. Now case number 2. If we divide p by q and q is not equal to 0, the case number 2 is the remainder never becomes 0. Here the remainder becomes 0 after some steps. Here the remainder never becomes 0. So here also it can be subdivided into two categories. Example, if we divide 10 by 3, we get 3.3333, which can be written as 3.3 bar. If we divide 1 by 7, we get 0.142857, 142857, and so on. So here this number, this block of numbers repeat itself again and again, so we can write 0.142857 bar, right? So in such cases, here we have repeating block of digits in the decimal. So such cases are non-terminating, because they never end. This block of number never ends and it goes on forever, right? So these numbers are non-terminating recurring. Recurring means repeating. Decimal expansions, right? And the second subcategory is, let's say, 0.10, 110, 1110, and so on. Root 2 equals to 1.414213562. The decimal expansion of pi is 3.141592653589 and so on. So if you notice, in such cases, these are non-terminating because they go on forever. And also, unlike here, like here we always had a block of numbers that repeated itself, right? But here we do not get any numbers which repeat themselves after a certain number of steps. So these are non-terminating and non-recurring. Non-terminating, non-recurring means non-terminating and non-repeating. So these numbers are irrational numbers.